Hello students, today's topic of discussion is an introduction to strain gauge. So strain gauge is a sensor whose resistance varies with applied force. We all know that these force, pressure, tension, weight, they all are related. They can be converted from one form to other form, and therefore we can use strain gauge to measure force, pressure, tension, weight, etc. So to have an example, we have this weighing machine here that we all have seen in market. It is used to measure weight of, say, grocery goods. This is the platform where you keep the material whose weight is to be measured, and strain gauges are mounted somewhere here. So this weight exerts a force on strain gauges and its resistance change. This change in resistance can be measured with the help of various resistance measuring techniques, for example, a Wheatstone bridge that we all have studied earlier. So this Wheatstone bridge converts change in resistance into equivalent change in voltage. So when external forces are applied on a stationary object, stress and strain are produced. We are going to see what is stress and what is strain in upcoming slides. Before that, let's have a look at this diagram. This is something called as a semiconductor strain gauge. So there are various types of strain gauges that we will be studying later. This is a semiconductor strain gauge with these leads which are available for electrical connections. So let us understand what is stress and strain. To begin with, let's understand what is stress. For that, consider this column wherein we are applying external force in form of pressure at this point of column. Now this column will always try to exert an opposite force which is called as internal force. Now this is a repelling force which tries to maintain the original shape of this column. Now when we divide this internal force which is generated by object which opposes the applied force by cross-sectional area A, what results is stress. So stress is denoted by sigma, which is the applied force, which is of course equivalent to the internal force, and cross-sectional area. The unit is Pascal or Newton per meter square. Now let us have a look at what is strain. For that, consider this bar. The bar's length is L and a diameter is D0. Now we are applying force in these two directions, which means that we are trying to elongate the bar, because of which the length of bar will increase, say by a very small value delta L, and its diameter will decrease, say by a very small value delta D. So this strain is a ratio of change in length and the original length. So if you see, basically strain is a unitless value. Now this strain can be of tensile nature or compressive nature. So here we are trying to elongate the bar. So this is a tensile strain. Now many times we try to apply force in this direction. So from this direction and in this direction, wherein we are trying to compress the object. This is called as compressive strain. Now this strain is unitless, but its value is very small. So usually we suffix 10 raised to minus 6 and the unit of strain becomes microstrain in that case. Now let's have a look at the relationship between stress and strain. When we apply force to any object, strain is produced, which gives rise to stress. So there is a certain limit wherein as you go on changing the strain, stress also changes. The relationship is linear. This is called as proportional limit. This proportional limit satisfies Hooke's law. Hooke is name of the scientist who came up with this concept. So equation wise, Hooke's law is stated in this fashion. The ratio of stress to strain is constant, which is nothing but modulus of elasticity. So this is the band which satisfies this equation here. Now I want you all to pause the video for some time and write down the formula and unit for stress and strain. Once you are done with this, fill in this blank. The relationship between stress and strain is given by dash. Write the relevant equation. I hope that you all have gone through the reflection spot. Now let me tell you, this resistive foil or the metallic strain gauge, it's not that mechanically strong. So if you go in market, you will find that this element is pasted on a plastic film to give it enough mechanical strength, and it is covered by a thin laminate film so as to isolate it electrically. So the basic working principle of strain gauge is strain measurement through resistance change. Usually these strain gauges are made up of copper nickel alloy foil, but depending on the range of measurement and the requirements of application, this alloy can be changed. Next important property is the gauge factor. Gauge factor is defined as a ratio of per unit change in resistance to per unit change in length. Expression wise, gauge factor is given by delta R by R divided by delta L by L, where this L is the original length of object before we apply any force, and capital R is the original resistance before we apply the force. After application of force, the length will change by delta L, and there will be corresponding change in resistance, which is denoted by delta R. So this is the formula for gauge factor. Now here we have arranged some of the terms. So gauge factor we have taken this side, so that delta R by R is equal to gauge factor into delta L by L, and we know that delta L by L is nothing but strain. So if you multiply the applied strain by gauge factor, you will get change in resistance per original resistance. Gauge factor can also be written by this equation. So what is this equation? The first factor 1 is because of resistance change due to change in length of the object. This middle term 2 nu is resistance change due to change in area, and this factor is resistance change due to piezoresistive effect. So this is the main formula for strain gauge. So if you want to express gauge factor in a nutshell, this is the formula. Now if you neglect the change in strain because of change in value of resistivity of a material, which is usually very, very small, the formula for gauge factor is this. So this is all about strain gauge, and the remaining part will be covered in the upcoming session. Thank you for going through the video. Thank you.